From space, Earth appears small, a tiny blue marble against the vast black canvas of space. This humbling perspective underscores the grand scale of the universe we inhabit. Our planet, teeming with life, is but a speck in the grand cosmic scheme. But even this tiny world is part of something much larger. Our journey into the universe begins right here. Let's take a step back and imagine ourselves aboard a spacecraft, leaving Earth behind. As we ascend, our planet shrinks in the viewport. Continents become indistinguishable, and soon we see the Earth in its entirety, a fragile oasis, enveloped by the darkness of space. This is our starting point, our cosmic address, a pale blue dot orbiting an average star. Our journey has just begun. Our first destination is our celestial neighborhood, the solar system. This vast expanse of space is home to a variety of celestial bodies, each with its own unique characteristics and mysteries waiting to be uncovered. Our sun, a blazing ball of hot gas, reigns supreme at the center. It is a massive glowing sphere of hydrogen and helium, undergoing nuclear fusion to produce the light and heat that sustain life on Earth. The sun's surface is a turbulent place, with solar flares and sunspots constantly changing its appearance. Around it orbit 8 planets, including our Earth. These planets vary greatly in size, composition, and distance from the sun. From the rocky inner planets like Mercury, Venus, Earth, and Mars, to the gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune, each planet has its own story to tell. Vast distances separate these celestial bodies, distances best measured in light years. For instance, the distance from the Sun to Neptune is about 4.5 billion kilometers, a journey that would take a spacecraft many years to complete. Light, the fastest thing in the universe, travels at an astounding speed of approximately 299,792 kilometers per second. This incredible speed allows light to traverse the vast distances of space, bringing us images and information from far-off places. It takes about 8 minutes for sunlight to reach Earth. This means that the light we see from the sun is actually 8 minutes old, a fascinating reminder of the vast distances in our solar system. This means we see the sun as it was 8 minutes ago. Every sunrise and sunset is a glimpse into the past, a beautiful demonstration of the speed of light and the scale of our solar system. The farther we venture into space, the farther back in time we see. As we look at distant stars and galaxies, we are seeing light that has traveled for millions or even billions of years to reach us, providing a window into the history of the universe. Think about Mars, our red neighbor. This intriguing planet has captivated human imagination for centuries, with its reddish appearance and the possibility of past or present life. Depending on its position relative to Earth, it can take light anywhere from 3 to 22 minutes to travel between them. This variability is due to the elliptical orbits of the planets, which bring them closer together or farther apart at different times. This delay makes communication with future Mars explorers a fascinating challenge. Scientists and engineers must account for this time lag when planning missions and sending commands to rovers and other equipment on the Martian surface. But even Mars is relatively close within the grand scheme of our solar system. Beyond Mars lies the asteroid belt, a region filled with rocky debris and dwarf planets like Ceres. It takes light over 4 hours to reach Neptune, the farthest planet from our sun. This distant, icy world is a mysterious place, with strong winds and storms raging across its surface. As we leave the outer edges of our solar system, we begin to grasp the true vastness of space. The Voyager spacecraft, launched in the 1970s, are now traveling through interstellar space, sending back data from beyond our solar system. But this is just the first leg of our cosmic journey. Beyond our solar system lies the Milky Way galaxy, a vast collection of stars, planets, and other celestial objects. And beyond that, the universe stretches out into the unknown, filled with countless galaxies and endless possibilities for exploration and discovery. Imagine our sun as a single grain of sand on a vast beach. Now picture that beach stretching endlessly in all directions, with each grain representing a star. This gives us a sense of the sheer scale and wonder of our galaxy. That's the Milky Way, our galaxy, home to hundreds of billions of stars. Each of these stars could potentially host its own system of planets, moons, and other celestial bodies, making the Milky Way a bustling cosmic metropolis. From afar, our galaxy appears as a faint band of light stretching across the night sky. This band, often referred to as the Milky Way, is actually the combined light of millions of distant stars, too far away to be seen individually. This cosmic light show comes from the combined glow of countless stars, many much larger and brighter than our own sun. Some of these stars are so massive that they burn through their fuel quickly, ending their lives in spectacular supernovae. These stars, along with gas, dust, and mysterious dark matter, are drawn together by gravity to form a gigantic spiral. This spiral structure is characteristic of many galaxies with arms that wind out from a central bulge. If we could view the Milky Way from above, we'd see its majestic spiral arms swirling like a cosmic pinwheel. These arms are regions of active star formation where new stars are born from clouds of gas and dust. Our solar system resides within one of these arms, roughly 26,000 light-years from the galactic center. This arm, known as the Orion Arm, is just one of several that make up the Milky Way's spiral structure. To put that distance into perspective, imagine a beam of light leaving our sun today. Light travels at an incredible speed of about 186,000 miles per second. Yet it would still take this beam 26,000 years to reach the center of the Milky Way. It wouldn't reach the center of the Milky Way for another 26,000 years. This immense distance highlights the vastness of our galaxy and the incredible scales involved in cosmic measurements, and that's just our small corner of this vast stellar metropolis. The Milky Way is teeming with regions of intense star formation, ancient star clusters, and mysterious phenomena like black holes and neutron stars. The Milky Way is about 100,000 light-years across. This means that even traveling at the speed of light, it would take 100,000 years to journey from one end of the galaxy to the other. To cross it, even at the speed of light, would take a staggering amount of time. This vast expanse is filled with countless wonders, from nebulae where stars are born to the remnants of supernovae where stars have died. As we journey out of the Milky Way, we begin to realize that our galaxy, with all its grandeur, is but one among many in the universe. The observable universe contains an estimated 2 trillion galaxies, each with its own unique structure and history. Our closest galactic neighbor, the Andromeda Galaxy, is on a collision course with the Milky Way. In about 4 billion years, the two galaxies will merge, creating a new, larger galaxy. This cosmic dance is a reminder of the dynamic and ever-changing nature of the universe. Beyond our local group of galaxies lies the vast expanse of the universe, filled with galaxies of all shapes and sizes. Each of these galaxies is a cosmic island, containing billions or even trillions of stars and countless mysteries waiting to be discovered. As we gaze up at the night sky, we are reminded of our place in the cosmos. The Milky Way, with its billions of stars, is just one part of the grand tapestry of the universe. Our journey of exploration and discovery has only just begun. With each new discovery, we learn more about the universe and our place within it. The Milky Way is a testament to the beauty and complexity of the cosmos, and a reminder of the endless possibilities that await us as we continue to explore the stars. Section 4: Galactic Neighbors, the local group. Beyond the Milky Way lies a sea of other galaxies, each with its own unique characteristics and mysteries waiting to be uncovered. These galaxies are not just random specks scattered across the cosmos, they form intricate patterns and structures that tell the story of the universe's evolution. Our closest major galactic neighbor is the Andromeda Galaxy, a spiral galaxy even larger than our own. Andromeda is a majestic spiral galaxy, its arms gracefully winding around a bright core. It is a sight to behold, especially when viewed through a powerful telescope. Its faint glow, visible on a clear night, represents light that has traveled for over 2.5 million years to reach us. This ancient light offers a glimpse into the past, showing us Andromeda as it was millions of years ago. Observing Andromeda is like looking through a time machine, revealing the history of our cosmic neighborhood. The Milky Way, Andromeda, and dozens of smaller galaxies are gravitationally bound together in a cluster we call the local group. This cluster is a dynamic and ever-changing environment, with galaxies interacting and sometimes even merging over billions of years. Think of these galaxies as houses scattered across a vast cosmic neighborhood. Each galaxy is like a home, with its own unique inhabitants, stars, planets, and possibly even life. The local group is our immediate cosmic community, a place where we can study the interactions and evolution of galaxies up close. The local group spans a region of space roughly 10 million light-years across. This immense distance is difficult to comprehend, but it highlights the vastness of our cosmic neighborhood. Within this space, galaxies are constantly moving, influenced by the gravitational pull of their neighbors. As we venture further, we encounter other galaxy groups and clusters, each containing hundreds or even thousands of galaxies. These clusters are like bustling cities in the universe, with galaxies interacting and sometimes colliding, leading to spectacular cosmic events. These clusters in turn form even larger structures called superclusters, stretching across hundreds of millions of light years. Superclusters are the largest known structures in the universe, vast networks of galaxies connected by the invisible threads of dark matter. The universe, it seems, is built on a hierarchy of structures, each more awe-inspiring than the last. From individual stars to galaxies, clusters, and superclusters, each level of this hierarchy reveals new wonders and complexities. But even these galactic superhighways are but small pathways within the vast expanse of the observable universe. The observable universe is a mind-bogglingly vast expanse filled with countless galaxies, each with its own story to tell. As we continue to explore and understand our cosmic surroundings, we uncover the intricate tapestry of the universe woven together by the forces of nature and the passage of time. Section 5. The Observable Universe, a Cosmic Horizon. The observable universe is a sphere centered on us, containing everything we can currently see. It represents the limit of how far light has had time to travel to us since the Big Bang, the event that marked the beginning of our universe. Current estimates place the edge of the observable universe at roughly 46.5 billion light-years away in every direction. To put that into perspective, the light we see from the most distant galaxies has been traveling for almost the entire age of the universe. Imagine the stories those ancient photons could tell, having witnessed the birth of stars and galaxies in the early universe. But here's the mind-boggling part. The observable universe is not the entire universe, it's just the part we can see right now.